Please. And then
Yeah,
we will start.
Okay, okay. Uh, okay, madam, my screen is visible.
Yes, sir.
Okay, okay. So, good evening, everyone. Welcome all to SOAWAL webinar. This is the webinar number 10. Today, we are going to discuss something on various localization techniques on wireless sensor network. As I can say that this is the continuation of the last webinar that we have discussed, something on WSN that we are focusing on, that increasing the data transmission rate through 6G for a wireless sensor network. And this is also another challenge in the wireless sensor network, that is localization. So before going into the presentation from the sir, let me introduce our university through a small video. So is it audible, madam?
Yes, sir.
It is audible.
Yeah, thank you again. As I have already told that the title of this webinar is the localization technique for WSN. And today we have one of the eminent speaker, Professor Dr. Pabitra Mohan Khilar, sir. So let me give a short introduction to our sir. Dr. Pabitra Mohan Khilar is currently working as an associate professor in the Department of Computer Science and Engineering at National Institute of Technology, Rourkela. He is the professor in charge of the Parallel and Distributed Computing Laboratory, Hardware Lab, Data Communication Lab, and PhDL Lab at NIT Rourkela. He has been involved with teaching undergraduates and graduate students in distributed diagnosis, distributed fault tolerance, high performance algorithm, sensor fusion, since his joining as a faculty in the Department of Computer Science and Engineering, NIT Rourkela, in the year 1999. He had been involved in the different system and application software and design of hardware equipment in reputed industries of India. He is the senior life member of many international and national professional bodies like IEEE, IET, CSI, IST, ISCA, OITS, and OBA. He has guided 10 PhD students, 2 MTech research scholars, around 68 MTech CSE students, and 200 plus BTech CSE students in the Computer Science and Engineering Department of NIT Rourkela. He is directing more than 5 PhD students, 5 MTech students, and 5 BTech students in the emerging research fields, such as fault-tolerant computing, parallel and distributed system, distributed wireless sensor networks. He has published more than 175 research papers in various highly reputed international SCI, Scopus, Web of Science journals, published by IEEE, Elsevier Science, Springer, InterScience, Wiley, IJCA, etc. He is the author of books and book chapters in computer science and engineering, which are published by reputed international publishers such as Tata McGraw-Hill, IGI Global Service. He has received gold medal from IE, IBM Faculty Award 2011, Certificate of Recognition from Infosys, IET Premium Awards in the year 2016, Amdocs Innovative Mentor Award 2018, and many awards received from various international conferences, workshops for his technical contributions. He has conducted more than 10 faculty development programs, short-term courses, where the participants are from both India and foreign universities. He has honored for many invited talks, keynote, chief guest speech, and all India radio speech by the organizing committee for many international and national conferences, workshops, seminars conducted by reputed institutions and universities in India. He has been assigned as reviewer, session chair, organizing chair, technical committee member, international advisory board for many international journals and conferences in India and foreign countries. He has been the examiner for the thesis evaluation of BTech, MTech, and PhD thesis of reputed universities in India. He has visited the foreign universities such as MIT, Boston, USA, NTU, Singapore, Malaysia, uh, and other engineering colleges for the academic matters. So let us start, sir.
Okay. We'll start now.
Yes, sir. Yes, sir. Now we can start.
Okay. So, very good afternoon to each and every participant. So, since this is a webinar, we cannot see each other, but still, I think my voice is clear.
Yes, sir. Yes, sir.
Okay. So,
Sir, just share your screen, sir.
Screen is shared, no? Screen is not visible?
No, sir.
Let me share again. Now, is it visible?
Yes, sir. Yes, sir.
Okay. So by mistake it is 24th September written, so you will understand it is 30th September 2022. Okay. So again I thank Dr. Vishwanjan Sanapati for a nice introduction about me, and I also I was going through the video. The video is also prepared very nicely, giving all the details about the Sikhan on universities, and there are a lot of added advantages that I could observe from the video, and which is really interesting. And anybody can, whatever capacity is a part of the SOA University will be really this video. From this video, they get really a lot of information about the SOA University. So as Dr. Vishwajan Senapati told, my today's topic will be localization in wireless sensor network. And you know that this is a very specific research topic. And there is a reason why I have given this topic, localization in wireless sensor network. Because the wireless sensor network, though it is a research area, but this has become almost outdated due to the last 20 years last 20 years research. A lot of work has been done on wireless sensor network, but we can say that there is no much work done in localization in wireless sensor network, despite it is a very important problem. So we can say that since the localization is a very important problem in wireless domain, and the lack of research in this area really makes these wireless sensor networks are not affordable and not useful for the social applications. And as you know that wireless sensor networks consist of a large number of tiny sensor nodes, and they are all connected by a communication network wirelessly. And the nodes in this sensor network is something similar to the nodes in the computer network. I think most of you have studied a paper, computer network, either in BTech curriculum or somewhere in the course of study. We know that there is a subject called computer network, and it is almost similar to wireless sensor network. So in the wireless sensor network, we replace the nodes in computer network by a wireless node, wireless smart node, which is equipped with different types of sensors, actuators, and processors, memory, and some special kind of devices, including the batteries also. And we know that most of the wireless sensor networks are usually battery operated, and that is you can say that is a limitation or disadvantage of the wireless sensor network. The advantage side, if you see, the size is small. Each of the smart node size is small, and cost is very also less. So due to less cost and a tiny size, in fact it is affordable even. Due to these added advantages, the wireless sensor networks are becoming popular day by day, and it is used in various kinds of applications such as forest areas, sea areas, water river areas, or some areas which are affected by the natural disasters due to cyclones, due to earthquakes, etc. And sometimes they can be also very much useful for the battlefields and many other. In fact, in the smart cities like Bhubaneswar, Rourkela, and Bombay, Delhi, in almost all city areas, we can also use this wireless sensor network for different applications. I can give just an example. Suppose you want to know the temperature of Bhubaneswar, or you want to know what is the pollution level at Bhubaneswar. So we can distribute this wireless sensor network across all the areas of Bhubaneswar, and we can connect them wirelessly, and they will form an ad hoc network. Ad hoc network means they don't need any kind of infrastructure like internet. It will itself, all the sensor nodes themselves will form an ad hoc network. And whenever this ad hoc network is formed, we can run some applications. We can run some applications. For that, we can write suppose some softwares or some ready-made softwares are there, or we can develop our own softwares, and which will be mapped to this wireless sensor network. And when the softwares are run or executed on this wireless sensor network, then the corrective actions can be taken place. For example, I want to know what is the average temperature of Bhubaneswar, and I have deployed the sensors at various places in the Bhubaneswar, and I can collect all the data items from each of the sensor nodes, and I can find out the average. just I can compute the temperature value from each of the sensor nodes, then divided by the number of total number of sensor nodes. That will give me the average temperature value. So likewise, you can we can measure also various other pollution, environmental pollution parameters such as carbon dioxide, carbon monoxide, sulfur dioxide, etc. So all these just I told you one applications of the wireless sensor network. Similarly, we can deploy this wireless sensor network for various other kind of applications like sea areas to observe various activities by the different animals which are inside the sea and in the surface. Likewise, you can have different applications. Anyway, this wireless sensor network has a number of applications, but ultimately, whenever these wireless sensor networks are formed, it is really difficult to find out the exact coordinates or the position of the sensor nodes in the deployment environment. For example, I deploy 1,000 sensor nodes in the city of Bhubaneswar, and each of these sensor nodes cannot be assigned with an IP address, unlike in internet. So in the internet, what we do, we assign an IP address to each and every personal computer, and in that respect, the IP addresses are almost exhaustive. All right. So similarly, for the wireless sensor network, they are available with large number, millions, billions of nodes, and simply we cannot assign one IP address to each and every sensor node in the WSU. So therefore, only few or limited number of sensor nodes will be assigned with the IP address, and assuming that each of the sensor nodes can be identified or their positions can be identified, while the rest of the sensor nodes positions are not identified. So identifying the location means the position, which can be x and y value if it is a two-dimensional deployment, and if it is a three-dimensional deployment, we can take the help of three parameters like x value, y value, and z value. Similarly, if you can go for higher dimensions, only the dimensions will increase and number of parameters will increase. So in effect, our interest is to find out what is the coordinate value, what is the value of x and what is the value of y, if it is a two-dimensional sensor network. So getting this x value and y value, which we call the position of an unknown node in the sensor network, is called localization. I think it is clear that what is the meaning of localization. So here the localization means to find out the x value and y value of an unknown node with the help of a known node. So, or we can say that the entire sensor nodes in the WSN can be divided into two groups. One group is the active group, which are in the active group, all the nodes, they know their position. Whereas in the unknown nodes, inactive group, that we say the nodes are not knowing the their positions. So it is the task of known nodes whose positions are already available to identify the locations of unknown nodes. So this is what we mean the localization in wireless sensor network. To be more specific, we are to allow a specialized set of nodes in the sensor network whose positions are already known, and with the help of this, we have to identify the location or the coordinate of the unknown nodes. So this is what we call the localization in wireless sensor network. I think it is clear now what is the meaning of localization in wireless sensor network, so that we can go ahead with the other slides. And if anybody has any doubt, also you can interrupt me in between.
Oh,
Okay, let us go to the next slide. So my topic, outline of this topic is like this. First of all, I told about what is wireless sensor network, then localization in WSN, and different types of nodes in localization. Then we shall see a literature review, how the people have worked and what are the people who are the people who have worked in the area of localization, and what are the different parameters to evaluate the localization algorithms like cost, accuracy, localization error, energy efficiency, hardware cost, etc. Then we'll be discussing two existing important algorithms. So there are the two existing algorithms which are already useful or which are already available to identify the location of unknown nodes with the help of anchor nodes. Anchor nodes is the nodes whose positions are already known. Then what is the motivation or objective of the work and what we did? This is a, though it is a small contribution to the localization area. So we will discuss more something about the proposed work, what we have done in this particular domain. So this is the wireless sensor network, which is a collection of various autonomous self-sufficient nodes which are sensing capabilities. That already I have told you that a wireless sensor network consists of large millions and billions of nodes, and each node is equally capable of sensing, actuating, processing, storing. Right. So in that sense, we can say that the nodes which are participating in the formation of wireless sensor network can always be a smart sensor, or sometimes we call mica sensor nodes, etc. And due to less cost and less size, they can be available or they can be deployed in a large quantity. So what is the localization? As I told you, the primary objective of localization is to determine the location of the target. So target means the nodes whose positions are not known. So nodes means it is a smart node, and it can sense, it can actuate, it can process, it can store the data items from the environment, but its location is not known. And once its location is known, all the information collected by this target node can be collected by the source node. So this target node location is not known, but it is capable of storing the data. It is capable of sensing the data from the environment. So all activities can be done by a node, and they can be accumulated temporarily in the storage medium of that particular node, and that can be again transferred to other sensor nodes or source nodes with the help of the different routing algorithms. Anyway, routing is not our objective. Our objective is to find out what is the location of this target. And once we find the location, we can identify the target node. And from the target node, we can get all the informations which are accumulated by this target node to the source node. I hope the meaning of localization is understood by everybody. And if you have any doubt also, you can ask me or interrupt. So this localization has a number of applications, but the major important applications for the localizations is the coverage. Coverage means suppose a very large area is there, we can deploy the sensor nodes to cover the entire area. So whatever the events or activities are taking place in that particular region of interest can be covered or can be monitored if the coverage is possible. So coverage is very, very important applications of the localization, where we have to cover a large area for monitoring different activities and events from that particular area. So that's what we call the coverage application. Similarly, underwater cultivation. You know that nowadays the rivers and seas, we have number of sea animals or number of river animals, they are being cultivated. For example, fish cultivation, etc., and a lot of activities which are going underwater environment like the river and the sea can be kept track or can be monitored through the localization. So unless the nodes are localized, we cannot keep track each and every activity which are being recorded by the different sensors nodes in the WSN. Similarly, the third application is the target tracking. That already I have told you. If I want to know some information from a target, so first of all I have to identify the node which is present in that target area. And once that node is located, we can get all the information about that particular area from that particular node. So therefore, localization is very important. And for target tracking, localization is also equally important. I can give an example for this also. For example, in a battlefield, if we want to find out the enemy's weapons, then the nodes which is covering that enemy's weapons can get all the information from that particular region and send to the control room, and which we are calling the source node. So which can collect all the information from the target area, or this is useful for the target tracking. So that's the third application. Likewise, a number of applications are there. And already I have told you that a rescue application, whenever the disaster situations comes like cyclone and earthquake or some emergency conditions takes place, then for the rescue operations, we need to deploy the sensor networks. And whenever we deploy the sensor nodes into the environment, in the disaster environment, we have to localize it. Unless we localize, we cannot get the information about that particular area in the disaster situations, in the disaster areas. So as I told you, so this as far as the localization is concerned, we can divide the entire sensor nodes into two types. One is called beacon node, another is called DOM node. So these beacon nodes are also called anchor nodes. Anchor nodes means their positions are already known, and we assume that a GPS system is attached to each anchor node so that the coordinate of each node can be known in advance, right? So then another type of node, or the remaining types of nodes in the sensor network, can be of the DOM nodes. DOM nodes means the unknown nodes whose positions are not known. So, this is a two-way classifications of the sensors nodes in the WSN as far as the localization is concerned. But in some other literatures, if you go through the literatures about the localization, you will find out different types of classifications. Some people also classify these beacon nodes into further another two types of nodes which are battery operated and which are operated with electricity. So based on that also we can further divide. So this classification can be enormously available in the literature, but here we shall focus on the two types of nodes. One is beacon nodes or anchor nodes or unknown nodes, and another type of node is the DOM node, which are the unknown nodes. So I think understood the meaning of beacon nodes and DOM nodes. So as per again the localization is concerned, our major goal is to develop the algorithms for localization such that the localization error is minimum and or the localization accuracy is maximum. So that means whenever you identify the location, that is the x and y value, this x and y value should be exact. It should be available preferably in the integer form. But unfortunately, we cannot get the exact value of the sensor node in the deployment field. So we will get an approximate value. And once there is an approximation, so there may be an error or the accuracy cannot be 100%. So to improve the localization accuracy or to reduce the localization error, so everybody or all the algorithms in the literature are striving, or you can say it is a challenge to reduce the localization error and to improve the localization accuracy among the researchers in this field or academicians in this field. So our job is to minimize the localization error and maximize the localization accuracy so that we'll be able to keep track the position of the unknown nodes. And for that, we'll take the help of known nodes. So here we are proposing an ensemble approach. Ensemble approach means there two approaches, two different algorithms which are already existing in the literature. We can combine them, we can hybrid them so that the localization error will be minimized and the localization accuracy will be maximized. This is our basic idea behind ensembling or by combining or integrating two existing algorithms. One is called DBHop, distance vector hop algorithm, and another is weighted amorphous algorithm. So these two algorithms have been merged together to reduce the localization error. So this is what we name ensemble approach. Then the different comparisons, these are the comparisons of algorithms which are available in the literature in terms of three parameters. One is cost, then another is accuracy, another is localization error. So if you see the SAPA and etc., the SAPA and other authors, they developed this algorithm and where the cost is high and accuracy is high and localization error is low. So likewise, if you see, sometimes the cost is high, sometimes the accuracy is high, and sometimes the localization error is high. So based upon this, we can classify all the algorithms which are available in the literature into these different areas or different classifications. Then you will not go to much detail because of the time constraint. I'm not able to discuss each and every what you call the algorithm for the which are available in the literature. So we'll go for another comparison, that the localization algorithms which are existing in the literature can be divided into two broad types, again based upon the ranging, that range based or range free. So range, what we understand that every sensor node will have a range for communication. If any sensor node which are coming under the sensing range of a particular, the communication range of a particular node, then we can say that the communication is possible. And different localization techniques are proposed for the range-based schemes and range-free schemes. And you can see in this classification RSSI, which is the received signal strength indicator, which is a very important parameter for the range-based systems. And DBF algorithm and amorphous algorithms, we have chosen these two algorithms for the range-free localization. And here basically we are going to discuss a range-free localization technique, because the range-based techniques are somewhat costly as compared to range-free, and there is a reason for that. All the range-based techniques assume that every sensor node is equipped with a GPS system, and as you know that a GPS system consists of both hardware and software. So this gives an added cost to the existing systems. So to avoid this cost and hardware and inconvenience in the deployment, we discuss or we propose a range-free algorithm, and we have studied these two range-free algorithms which are already existing. One is called DBF, another is amorphous. So these two algorithms are already available in the literature, and they are basically used for finding the location of the unknown nodes. And based upon the RSSI value, that is received signal strength indicator, and some other parameters that we are going to discuss in detail. So this range-based, range-free, as I told you, the range-based algorithms and range-free algorithms can be compared by taking these parameters. One is cost, second is power consumption, third is deployment, and fourth is external hardware. So cost of the range-based system is high because of the GPS system or because of the hardware. And since we are using hardware, again the power consumption is also high. And since it is hardware, again deployment is also hard. And since it uses the external hardware, so again the deployment cost is high. So if you see the range-based techniques, unless it is an indoor environment or unless you are deploying in a very close boundary region, then range-based algorithms are not preferred. Rather, whenever you deploy in the sea areas, forest areas, or any natural disaster situations areas, then range-free algorithms are comparatively better. So therefore, it is better to develop the range-free algorithms as compared to the range-based algorithms. So, but there is one advantage of range-based algorithms where this can be very much useful for emergency situations or the safety critical applications, where the cost is not most important, rather the life of people or a huge amount of infrastructure loss. So all these are important instead of focusing on the range-free techniques. So, but these applications are limited in size for the range-based systems. So most of the applications will follow the range-free, where we don't need any GPS system or hardware, and deployment must be easy. So here in the this range-free algorithms, though we assume that the GPS systems are not useful, but few limited number of sensor nodes in the range-free algorithms also requires the GPS systems, because we need to assume that some percentage of nodes out of all the nodes will be equipped with the GPS system, so that at least the location of each of these nodes can be known. So therefore we focus on the range-free algorithms, and we will be discussing more about the range-free algorithms. Okay, before going to discuss the proposed algorithm, the existing algorithm, which we call the distance vector algorithm. So this basically finds the hop size and hop count. The two important parameters for this algorithm. So hop size means whenever we take path between a source node and destination node, the two adjacent nodes will form a link, and that link is known as a hop, right? And that hop size of a particular link can be obtained by this formula, and from this we can find out what is the hop size between two adjacent nodes in the WHL. So this is simply the equivalent distance. You can see that there are two nodes, for example xi and yi, that is the coordinate of the beacon nodes, and xj yj is the coordinate of the unknown nodes, and between these two nodes we can find out the equivalent distance, and likewise you can find out the equivalent distance between every two adjacent nodes in the path to find out the total value, that is summation of the all the hop value or hop size of the entire path between source and target nodes. And if we divide it by hop count is the total number of hops. So hop size will give you the distance between two hops, and hop count will give you the total number of hops, and from that we can find out the average hop size. And by using these two parameters, we can very well find out the distance between the known nodes, that is the beacon node, and the unknown node. So the distance between the beacon node and unknown node is nothing but the hop size into hop value. And by using that above equation, that is this equation, we can easily find out the hop size and hop value, and if we multiply this, we can find out the distance. So this is how we compute, by using this formula, we compute the distance between target node and beacon nodes. That is called distance. Similarly, in the Amorphous algorithm, this is following another approach to find out the same distance between the beacon node and the unknown node. So this again, just for short form, due to time constraint, I am not showing the exact complete derivation of this particular equation, but we can understand in this way that hop size, according to Amorphous algorithm, the hop size, the link between two adjacent nodes can be found by this particular equation, where R is the communication range and n local is, here we have defined the n local. Yes, the n local is the number of neighboring nodes for a particular node, and that we call the average connectivity. So n local will give you the average connectivity, and that this n local can be found by this particular equation, n by s into pi into r square, and s can be obtained by this formula. So this is basically this particular equation is computing the hop size or the average distance considering three factors. So one is that e to the power minus n local, another is this term. So there are three factors have been considered to derive this formula. One factor is that what is the probability whenever we try to find out the location of the distance node or the target node, what is the probability that we are progressing in correct direction towards the destination? That is the first factor. And second factor, whether is there any availability of any known or unknown node in the range of this known node? That is the second factor. And third factor is that whether we are moving in a reverse direction to the target area or target node. Because if we are moving in a reverse direction and the target node is in the forward direction and we are moving in the backward direction, so we may not get the location of the target node. So taking these three factors, this particular equation have been derived, and again based upon the RSSI, that is received signal strength indicator, which is nothing but the amplitude of the signal. So by using the amplitude of the signal, we can derive what is the probability that we are able to get the location of the destination node with respect to the source node. And based upon that, this equation have been derived, and we find out the hop size. And this is the approach followed by Amorphous. Okay. Similarly, we can find out SIK value, and from these two equations, we can find out SIK and hop size. Again, here also we can find out what is the distance between beacon node and the unknown node. So by using the DB hop algorithm, we found the distance, and by using the Amorphous algorithm, we also found the distance. So we got two distance measurements by using two different approaches, and finally we tried to develop an algorithm and which localization error should be less and localization accuracy should be high. So this really motivated us to develop a new algorithm where the localization accuracy is high and localization error should be less. So with this motivation, we attempted to propose a new algorithm for the localization. So the objective is to propose a hybrid localization approach, which we call the ensemble approach, based on the DB hub and weighted amorphous algorithm for measuring two different distances, and by using these distances, we are finding out So by using these two distances, we are trying to find out the uh, exact position of the destination point. And the next objective is to reduce the localization error. We have taken three error parameters. One is MAE. MAE stands for mean absolute error, and MAC stands for mean square error, and RMSE stands for root mean square error. So there are three error parameters, and they have been also taken into consideration for finding out the localization error. And once you find the localization error, you can also find out the localization accuracy. So this is our objectives. Our objective is to find out, to develop an ensemble approach such that the localization error will be minimized and localization accuracy can be maximized. And the basic goal is to find out the distance, and by using the distance, we have to find out the coordinate, the x and y value of the target or the unknown. So this is the proposed flow diagram of ensemble approach. Here, whatever I told you, basically we are finding the hop value, and hop value is here, it is approximated. As I told you, we can never get the exact value of the target node. So therefore, a 0.5 is added in the equation to round off the number to the nearest integer. So again, we use the probabilistic distance estimation to get the D value and localization the unknown node using LSM and calculate the localization error in form. So this is whatever I told you, this is depicted in a flowchart flow form, and from this we can find out what is the proposed ensemble approach. So in the proposed ensemble approach, you can observe that hop size is computed as we computed in the previous equation. In the same way, we can compute it here also. Then hop value is computed like this. As I told you, we are subtracting 1 minus per. Either you can add 0.5 or subtract 0.5 to round off or truncate the value of the hop value of the SIP. So by using the weighted hop value and hop size, you can find out distance 1 by using DB hop algorithm. Similarly, by using hop size and hop value, we can get distance 2 by using the amorphous algorithm. So these two distances which are found for the DB hop and amorphous algorithm are basically the distance between the average distance between the beacon node and the unknown node. Now the question comes, which algorithm to find out the average distance? So which algorithm should be given more importance? So based to decide on that, the average distance is found by multiplying alpha into distance 1 and 1 minus alpha into distance 2. Now this alpha value is nothing but a probability value which is assigned to distance 1, and you can go on increasing or decreasing the value of alpha to give more weightage to either distance 1, which was computed using DB hop, distance 2, which was computed using weighted amorphous. So in this case, we are assume that this alpha value is taken as 0.9 to give more importance to the distance 1 measurement, that is DB hop, and 1 minus alpha a value will be 0.1 and which will be given to distance 2. But there is no hard and fast rule that which distance will be given as priority. So we can do the error trial method until we find a good distance, and once the distance is accurate and the location will be also accurate, because this average distance will give us the distance between beacon node and the position of unknown node. And once you find out the distance by using the least square method to get the location, we can get the location of the unknown node. So this least square method is a very standard statistical method available in the literature to find out the exact coordinates of a particular node if the location of a known node is known and the distance between location of a known node and unknown node is known. So by using these two parameters, two values, we can find out the exact location of the unknown node. And every time whenever we find out the location of an unknown node, there may be some errors. And these errors should be minimized. And to keep track, what is the localization error? We have taken three parameters. That is mean absolute error, mean square error, and root mean square error. So this is the least square method. So by using these equations, least square method, we can very well find out what is the x value, and this is an example is given. By using this example, we can easily find out the x value and y value. But anyway, the x and y value can be known, but we have to keep track what is the error in estimating the localization value. So the errors can be computed by using these formulas. These are the standard statistical formulas available in the literature, and where a is the actual value and is the estimated value. So this estimated value and actual value difference will give you mean absolute error, and these are based upon the actual values are based upon the data set which are already collected, and based from that data set you can find out the actual value, and by using this proposed approach you can find out the estimated value. And our job is to find out what is the difference of the value between the actual value and the estimated value. So based upon this we can get three parameters. So again, this algorithm was simulated in a particular environment using MATLAB, and the deployment area was considered 1000 to 1000 meter. Total number of nodes are assumed 300, and 20% nodes are chosen as beacon nodes, that is 60. 60 out of 300 nodes are beacon nodes, means the position of the nodes are known, and remaining on nodes are unknown, that 240 nodes are unknown. And the wireless range of a particular sensor node is assumed 200 meter. So based upon this simulation model or environment, we simulated, and this figure shows how the nodes are deployed into 1000 cross 1000 area, right? So these nodes are deployed randomly, or you can say that the distribution of the nodes follows the exponential distribution, where locations can be unknown, and the known location, the known sensor nodes are equipped with the GPS system, therefore their location can be known. So this is the deployment environment. Again, this is the other situations. Then we found out various results, like the amorphous algorithm. The localization error is 0.3239, and MSC value is 19.45, and RMSC value is this. And improved amorphous this, and proposed ensemble approach. So there is a difference. There is an improvement in the MA, MSC, and RMSC in the proposed ensemble approach as compared to existing amorphous algorithm and improved amorphous algorithm. So this is the from this figure we can find out what is the improvement level, and there is a significant improvement. You can observe the ensemble approach is the pink one, and improved amorphous is the green one, and amorphous is the red one. So from this figure it is clear that the mean squared error and mean absolute error and root mean square error for the proposed ensemble approach is much less as compared to the MA, MSC, and RMSC of the amorphous and improved amorphous. Similarly, this shows the mean absolute error and with respect to wireless range. So here also the localization errors are less if you consider the wireless range. Similarly, with respect to number of nodes, network size. So we have taken up to 500 nodes. It can be also further increased. And this is the conclusion and future work. So this work uses two types of algorithm. One is weighted amorphous and DBF. Then we proposed one probabilistic distance estimation method by combining these two methods, DBF and weighted amorphous. Then in order to keep track the localization error or localization accuracy, three important error parameters were taken from the statistics, that is mean absolute error, mean square error, root mean square error, and we found there is a significant improvement in the localization accuracy, such as 33.43%, 52.36%, and 30.98% with respect to amorphous and improved amorphous algorithm. Then there is a significant improvement in the accuracy and localization error and the performance evaluation parameters are also taken into consideration. And these are the references. So these are the references the people have done work. As I told you, much still a lot of work can be done in this area. So I think we can go for. So thank you everybody for listening the talk. And
Thank you, sir.
hmm.
So, dear professor and students, any question you want to ask, you can ask now, or you can write in the chat box. Okay, so there is no question. Sir, just I want to ask that the approach that we have used here, can we use any mobile ad hoc?
Hello, Vishwaranjan.
Yes, sir. Yes, sir.
Can you repeat? Actually, it is not audible.
So the approach that we have that you have told today, can we use it in the mobile ad hoc network?
Mobile ad hoc network. Yes, thus actually the WSN wireless sensor network is an ad hoc. Almost 99.9% networks are ad hoc networks, and these are if the sensor nodes are mobile. If the nodes are mobile, this is also one kind of manage. The WSN
Yes,
whatever we discussed, that is also one kind of manage. So
yes,
if
sir.
it is
Yes, sir.
applicable, if it is applicable for WSN, it can be also very well applicable for manage.
Yes,
Or
sir.
we can
Yes,
say
sir.
that WSN is a special case of manage, right?
Yes, sir. Yes, sir. Yes,
WSN.
sir.
Yes.
Okay. Okay. So, anyone else who want to ask?
Sir, I had a request actually.
Yeah.
Sir, I'm a faculty here, and in our research scholars, some of our research scholars are working on IoT and WSN. So they actually wanted a topic on related. Yes, sir. Sir,
For
if any of our students want to visit your lab,
sure, why not? If anybody
sir,
interested, they can send a mail to me, right? They can send a mail to
sir,
me, and if they are interested in actually, my domain is not restricted to WSN only. I also work on VANET, vehicular ad hoc network, and PLANET, flying ad hoc network. Nowadays, you can see that most of the domestic flights in the different countries, they are also connected. They are also using the ad hoc network. So the biggest advantage of this ad hoc network is that it is secure, because once the things if are connected to the internet, you are no longer secure. Even you may think that I am developing a very good or very efficient security algorithms, but still the intruders are able to trap it, right? So therefore, most of the things are not secure. Therefore, it is better to go for ad hoc network. That's I'm telling. If you are establishing an ad hoc network, for example, for the Bhubaneswar city, we don't have to depend upon the internet. Only one few nodes will be connected to the internet for communication purpose. Otherwise, all other nodes can form an ad hoc network, and whatever the messages, whatever all the digital or the information communication can take place within the city by using the ad hoc network with much less cost and in a secure fashion also, right? So
sir.
therefore the ad hoc network is a very important kind of network. If anybody is interested, a lot of work can be done on the ad hoc network. In fact, it is not at all started in India. While in foreign countries like German, France, USA, and some other countries, European countries, they have already started using this uh, ad hoc network concept. They have started implementing. Right, so there is a lot of open challenges for this area.
Sir. Sir, so if our students want to reach out to you, we can connect, sir.
You
Thank you,
can
sir.
connect, you can send a mail to me simply, or you can have my number also, telephone number, right?
Thank
This is comparatively a specialized topic. Localization actually it is a very research topic. I thought that since it is a webinar, nowadays people are also trying in BTech, MTech, PhD. All people are interested to work on the highly research areas. Even one or two students, BTech students, MTech students, they are also working here in the localization area. So I thought that these ideas will be shared among the people, so that at least few people may be interested to take up their projects. It can be BTech, it can be MTech or PhD, whatever. Okay.
Yes, sir. Yes, sir. So anyone else who want to ask or? Okay. So thank you, Professor Khilar, sir, for this nice presentation. As this is a really nice topic for any research scholar, it may be BTech or MTech or PhD, as sir told. So if anyone interested, they can directly mail to Khilar, sir. There is no issues. Or you can send me a mail and I will forward to sir. So from the Department of Computer Science and Engineering, Department of Shiksha Anusandhan University, I extend my gratitude for your presentation, sir. At the same time,
Thank you.
I want to, thanks the organizing team, Professor Sarada Prasannapati sir, Bharat Jyotiranjan sir, Dibyar Sundar sir, and